Hi everyone, welcome back to my YouTube channel. Family, today we are meeting again and we are now focusing on grade 11 trigonometric functions. We've already explained um, how to draw the graphs, right? In grade 10. So at least you need to know the original graph of sine, cos, and tan, period, range, amplitude, right? So for sine, the period is 360 and cos. And then for tan, I didn't mention that part. The period of tan is 180 degrees, right? And then these are the original graphs of sine, cos, and tan, where you're given the domain, the range, as well as the amplitude. Um, Before we move to grade 11, you need to know how to draw the original graphs of these functions, ne? And then when we get to grade 11, that's when now we start interpreting, right? But um, for grade 10, um, I think I'll create another video where I'll be explaining the effects of an amplitude, the effects of Q, that's the vertical shift, and the effects of P, which is the horizontal shift. One, two, three. I'll still create another video. I've already covered this part so far for grade 10, right? But this is continuation, so I won't repeat, right? So we have to continue. So here it was just the prior knowledge to test the prior knowledge and also to check the prior knowledge. So now grade 11, now that's when now we focus on the effects of K. Now what is K? K is the value in front of the angle. Value in front of the angle. Y is equals to sine kx. So for an example, they can give you y is equals to sine, and then they say 2x. So this value here becomes your k because it's the value next to the angle. Now um, if k is between 0 and 1, then the graph will be stretched and the period will increase. So the graph will stretch like this, right? But now if k is greater than 1, then the graph will be compressed and the period will decrease. So you'll have something like this. Now this graph is compressed, right? And then we move to the period of a graph. Grade 10, the period doesn't change, but in grade 11, that's when now the period changes. So in order to calculate the period of a graph, we use the formula new period equals to original period divided by k, right? So in grade 11, we mainly focusing on, yes, we do draw the graphs, right? And then we also interpret them. So for now, I want us to interpret the graphs. So here's an example here. Example number 1. Now they're saying the graphs of f of x is equals to a sine x and g of x is equals to cos kx as sketched below for x is an element of 0 is to 180 degrees. Determine the value of a. The value of a. So remember what I've said earlier about the original graph, right? The original graph of sine and cos, even tan, they start at 0. They start at 0, right? And then the the amplitude becomes 1. That's the original graph, right? But when I check this graph of sine, the green one, it starts at 0, but the amplitude there is 2. The amplitude there is what? Is 2. So now we can say A is equals to 2. A is equals to 2. So now we've managed to get the value of A at least. Now we've got the value of A so far. And now they're saying K. We must find the value of K. K is the value next to our angle, right? But now the standard cost graph has a period of 360, and the above graph has a period of 180 degrees. Now, how do we get the value of K? So we use the formula, new period, it's the new period, it's the new period equals to the original period divided by K. So what is our new period? Our new period, you have your what? 180 degrees equals to the original period here. That's our 360. And then you divide by K, right? And then now, that's when now you can multiply both sides by K, and then you'll have your 180 K equals to 360 degrees. And then you divide both sides by 180. And therefore your K is equals to 2. So which means your K is equals to 2. Now we've answered this question. I believe that you understood A. Now B, determine the length of AB. So we are looking for the length of AB. Again, it's not a problem. We can get that length. No? We need to use top graph minus the bottom graph. So for B, the length of AB would be top graph, which is our f of x, minus the bottom graph, which is our g of x. But now, obviously, the vertical distance, we focus on y, right? The vertical distance, we focus on y. So you have your 2 there, and then you have your -1 there. So we say 2 minus 1. And then this will give us 3 units. And then this is just the distance of AB. Now we found the distance of AB. Now determine the coordinates of D correct to 2 decimal places. The coordinates of D, at least we need to know one thing about D. So D is just the point of intersection. It's the point of intersection. But already they gave us the x value there at D. So we are only looking for the y value at D, right? But since this is the point of intersection, which means the graphs are equal, which means f of x is equals to g of x. So we can use either of the graphs. So I'm comfortable in using the graph of f. I'd rather use the graph of f, right? So let's try and use the graph of f. So now f of x, we have your 2 sine x, right? Okay, but already they gave us an x value there of 158. So we're looking for f of 158, 53 degrees. And then we substitute in place of x, 158,53, right? And then you use your calculator. I'm getting the value of 0,73. Now I can say, therefore, D would be 158,53 is to 0,73. So this is the coordinate D. Now, for which values of x is f of x greater or equals to g? So if we can go back to the functions, ne? What does this mean? It means f of x is above g of x. So we are looking for values of x where f of x is above g of x, right? Now let's go back to our graph and try to interpret, or rather analyze. Now, where is our f of x above g of x? So let me try and draw a line here. So now I'm trying to analyze the graph. Now, here, g of x is above f of x. Even here, g of x is above f of x, right? The pink graph is above the green graph, right? So now, but from here, actually, from point C to point D, the green graph is above the pink graph, right? So with that being said, we can say, yeah, f of x is above g of x. So how do we express that in a mathematical form? How do we do that? So for for D, this was C. So for D, we can say x is between 158,53 degrees and 21,47 degrees. That's where the graph of f is above the graph of g. Yeah, it's correct. I'm including my solution here. My solution is included here because of this original sign given to us. It was already included, right? Now, for which values of x is f of x divided by g of x less than 0? And then again, what do they mean by that? They are simply looking for x values where one graph is positive and the other is negative, or f of x equals to 0. They're looking for those points, right? Number one, x is equals to 0, or x is equals to 180, and x should be between 45 and 135. But let's try and analyze it together. We're looking for values where one graph is positive and the other is negative. So here, 0. One graph is positive and the other is negative, right? So x is equals to 0 here, right? And then where x is equals to 108 here, the other graph would be negative while the other is positive, right? That's correct. And then even here, between 45 and 135, one graph is positive while the other is negative. So one graph is above x-axis while the other one is below x-axis, right? So now how do we express this in a mathematical form? Again, for E, we can say x is equals to 0 degrees. X equals to 108 degrees. Or x between 135 and 45, right? 100%. But note that x is not equals to 45, nor equals to 135, as g of x is equals to 0 at these points, and you cannot divide by a 0. I believe that you understand that part, right? That's why I did not include here. I did not include. Perfect. Now let's move to another example. Let's move to another example. Here they're giving us the graphs of a graph of f of x equals to tan x minus p plus q and g of x a cos x are sketched below for x is an element of 0 is to 215. Okay. Again, before you even answer this question, you must know the original graphs by heart so that you can be able to spot the vertical shift or the horizontal shift, right? Now, A, determine the equation of g of x. So here's our g of x here. Now, g of x, that's our cos graph, ne? The standard cos graph starts at 0 is to 1. And it can be seen on the graph that this is a standard cos graph which has been reflected about x-axis, right? Which means our cos graph here is negative. So therefore, the value of A would be -1, right? So now we can say A is equals to -1. Therefore, the graph of g of x would be minus cos x. So this is the equation, right? Determine the equation of f of x. Again, the standard tan graph has an asymptote at 90. In the above graph, the asymptote is at 135. This means that the graph has been shifted right by 45 degrees. So which means P is equals to 45. right? So we can say for P is equals to 45. P is equals to 45, right? And it can also be seen that the graph has shifted 1 unit down. The graph has been shifted 1 unit down. Why are we saying that? Obviously, the tan graph starts at 0 is to 0 at the origin, right? But this graph has been shifted 1 unit down. So now this graph is at this level here. You can see the curves are at -1, right? So meaning now there is a what? A vertical shift. So it's important for you guys to understand the original graphs so that you can be able to interpret the graphs. So by having these two values, now we can get the equation of f. So f of x is equals to tan x minus 45 degrees minus 1. So this is the equation. And then now, for which values of x is f of x equals to g of x? Point of intersection. So x is equals to 9 there, or x equals to 270. These are points of intersection where the graphs are equal. And then D, for which values of x is g of x lesser or equals to f of x, right? But this occurs where the graph of g is below or equals to the graph of f. So we go back to our graph and then we check where is the graph of g below the graph of f, right? Now let's go back to our sketch. Um, between 90 and 135, this is the graph of f, this is the graph of g. The graph of f is above the graph of g. Or we can say the graph of g is below the graph of f. That's the first point, right? And then also between 270, between 270 and 315, the graph of f is above the graph of g, right? Or you can say the graph of g is below the graph of f. So now D, we can now say x is between 135 degrees and 90, or x is between 315 and 270. Perfect. E, write down the equation of h of x. If h of x is the graph of g of x, shifted 30 units to the left and 2 units up. Oh, okay. Now, h of x you will have your G, but now X plus 30, and then plus 2. But then now remember our G, we have your what? Your negative cos. Then this is X plus 30 degrees plus 2. And then we've answered all the questions. Guys, that's how you interpret your graphs. So you have to go back and revise the original graphs, how to draw the original functions, so that you can be able to interpret, right? Be able to know the effects of amplitude, effects of Q, and the effects of P, the vertical and the horizontal shifts. So guys, thank you for watching my video. We've come to an end. Bye. I hope we had a lovely weekend. Bye, everyone.